Have you ever watched a colossal vessel hundreds of meters long maneuver through a cramped port seemingly effortlessly? It defies logic. You might assume the captain alone guides these giants, but that's a common misconception, a grand illusion. In reality, at speeds as low as 2 or 3 knots, these massive ships become almost uncontrollable without assistance. Their immense inertia makes them nearly impossible to steer or stop on their own in confined spaces. Imagine a dark hull slowly gliding along a dock, water churning violently beneath its propellers, mooring lines stretched taut. A single misstep, one incorrect maneuver, and this colossal mass becomes an unstoppable force, a potential disaster. Today, we'll uncover the secrets of how incredibly small tugboats manage to steer ships hundreds of times their own size. By the end, you'll grasp how one perfectly executed move can either save or doom a multi-billion-dollar vessel. Let's peer into the critical junctures where the fate of these multi-ton behemoths is decided: the world's narrow waterways and tight harbors. Consider an object weighing a staggering 1,000 tons, like the Troll A gas production platform. Standing at 472 meters tall, it significantly overshadows even the iconic Eiffel Tower. In 1996, humanity faced the daunting task of towing this concrete leviathan out to open sea. It was, in fact, the heaviest man-made structure ever moved across the planet's surface. To achieve this, a fleet of 10 tugboats boasting a combined 100,000 horsepower was required. They performed flawlessly. The tugs progressed at a mere 3 kilometers per hour, knowing any slight error in synchronization could cause the platform to dangerously tilt. The previous feat undeniably demonstrated the unparalleled capabilities of tugboats in handling immense structures. Consider a typical container vessel, which weighs approximately 250,000 tons and stretches 400 meters in length. Even if its captain completely cuts the engines 5 kilometers from its destination, the colossal ship will continue its forward momentum. This unstoppable movement is entirely due to the immense, unavoidable force of inertia. At slower speeds, the ship's rudder becomes almost ineffective, rendering it unable to independently alter its course. Consequently, the massive vessel effectively loses all steerage and becomes completely uncontrollable. It will relentlessly drift towards the docks, a trajectory the captain is entirely powerless to change. The sheer size and momentum mean the captain simply cannot prevent its forward progress toward collision. Even an impact at a mere 4 kilometers per hour could render an entire port inoperable for many months. The question then arises, how does one halt something with a mass comparable to 2 towering skyscrapers? This is precisely the critical moment when specialized tugboats are called into action. A typical tugboat, by contrast, measures a comparatively modest 35 meters in length. Compared to the enormous cargo ship, a tug appears minuscule, much like a matchbox beside a vast trunk. Yet its technical specifications are astonishing. Powerful diesel engines generating up to 10,000 horsepower fill almost its entire hull. This combined force rivals that of 40 elite sports cars, providing the immense thrust needed for critical maneuvers. To initiate movement, the tug employs a controlled surge technique for optimal force application. It gradually tightens the tow line, ensuring a secure connection before fully engaging its powerful engines. The engines roar to life with a deafening sound, expelling thick plumes of smoke into the air. These thousands of horsepower literally compel the colossal vessel to yield to the tug's immense will. It's crucial to understand that a tugboat is far more than a simple, ordinary motorboat. Proportionally, it stands as the most powerful machine afloat, relative to its compact size. As the tug draws alongside the ship, the most intricate and critical phase of the operation commences. From the container ship's deck, sailors carefully lower a lightweight pilot line towards the tug below. This specialized rope, 7 times lighter than metal, boasts superior strength when compared to steel. A critical and invaluable feature of this particular line is its inherent buoyancy. It simply doesn't sink. This prevents any accidental entanglement with the propellers, which would instantly disable the vessel's control. Once securely fastened, this tow line establishes a robust and unyielding physical connection between the 2 ships. The diminutive tug must now force the immense steel mass to overcome its stubborn inertia and start moving. How then can they guarantee the rope's integrity, ensuring it won't snap at a critical juncture? A specialized mechanism subjects the cable to immense tension, rigorously testing its limits to prevent failure. The specialized mechanism applies a staggering 150-ton load to the cable, pushing it to its absolute limits. Adhering strictly to the material strength boundaries is paramount. Even a slight deviation can be catastrophic. If the load surpasses its limit by just 1%, the rope's internal structure will be instantly and irrevocably destroyed. When such a failure occurs, the sudden rupture produces a sound comparable to an extremely loud, sharp crack. In maritime operations, a dangerous phenomenon known as the snapback zone is well understood. This unpredictable area is where a broken rope's end will violently whip, following an erratic and deadly trajectory. The velocity of this whipping rope can reach an astonishing 800 kilometers per hour, posing an extreme threat. The sheer force generated is powerful enough to demolish steel components or shatter the reinforced glass of the bridge. For this critical safety reason, all personnel are strictly prohibited from being on the open deck during line tensioning. The captain, meanwhile, directs this delicate process from within the safety of a specially protected room. He perceives the immense strain on the system through the subtle yet distinct vibrations felt through the floor beneath his feet. The main challenge is to maintain a constant, stable force, a task complicated by unpredictable winds and waves. Often, the tug's role shifts from pulling to precisely pushing the massive vessel against the quayside. In such maneuvers, the tug presses its reinforced bow against the ship's side, engaging its powerful engines at full throttle. This forward section of the tug is protected by several tons of heavy-duty rubber, known as its fendering system. This heavy-duty rubber section, known as the fendering system, functions as a powerful shock absorber. The tug literally digs its reinforced bow into the colossal ship's steel hull, effectively transforming itself into a dynamic, living pusher. Its powerful engines are pushed to their absolute limits during these operations, while that resilient rubber nose absorbs immense pressure, steadily and gently guiding the massive vessel towards the quay. These crucial shock absorbers prevent any metal deformation on either ship. But a major technical challenge arises. How does this small vessel maintain its stability without capsizing, especially when a gigantic object unexpectedly pulls it in another direction? The solution lies in the unique design of its propellers, allowing the tug to instantly alter its thrust direction a full 360 degrees. Picture a vessel that can instantly move sideways or even pivot completely in its own footprint, all while securely holding a staggering 200,000-ton object on its tow line. Does that seem like an impossible feat for such a compact craft? A standard ship demands vast open water for even the simplest maneuver. However, a tug operating in a confined port lacks such space, prompting engineers to replace traditional rudders with azimuthing thrusters. These are essentially two massive propellers, each housed in its own pod, capable of rotating independently a full 360 degrees. This sophisticated setup grants the tugboat the agility of a vehicle where every wheel can turn in any direction. However, such unparalleled freedom of movement creates a perilous dilemma: how to maintain stability under the colossal forces exerted by a giant vessel. An even more intricate system exists, featuring propellers with vertical blades known for their exceptional responsiveness. This advanced mechanical design allows for 100% thrust in any direction, achieved in a mere single second. This rapid response capability is crucial for averting disasters, like when an unexpected gust of wind pushes a tanker towards shallow waters. Yet, this extraordinary maneuverability comes with its own significant cost, introducing a dangerous phenomenon known as critical tilt. Should the working tow line become snagged on the side of the tug, and the large ship suddenly accelerate, the consequences can be dire. The tugboat could be violently pulled over and capsized into the water within a matter of seconds, an extremely hazardous situation. To safeguard the crew, an emergency release button is prominently installed on the control panel. A single strike on this lever instantly severs the physical connection between the tug and the colossal vessel it's towing. There was a memorable incident in Southampton Port where a captain activated this lever just as the windows of his wheelhouse began to disappear beneath the waves. It was a desperate split-second decision made as his boat was on the verge of being submerged, highlighting the extreme risks involved. This profession is one of calculated risk, where every single movement must be meticulously precise down to the millimeter. Within the harbor, tugboats operate according to a precise, coordinated strategy. One tug pulls with its tow line, while others perform different roles. A critical incline poses immediate danger. If the tow line snags the hull and the large vessel accelerates, the tug will capsize instantly. This catastrophic event would unfold in mere seconds, submerging the tugboat and imperiling its crew. The harbor's coordinated plan involves one tug pulling with its cable, while another vigorously pushes the ship's side with its bow. This push-pull combination creates the perfect leverage, enabling a massive 400-meter tanker to pivot almost in place. However, even a slight hesitation from a single captain could send the steel behemoth out of control. Such an uncontrolled movement would inevitably lead to the destruction of the vital harbor piers. Yet even the most meticulous planning can fail when confronted by the unpredictable forces of nature. This is precisely what transpired when one ship halted global commerce, causing extensive logistical disruptions for 6 long days. On March 23, 2021, a pivotal day, all international goods shipments came to an abrupt standstill. The 400-meter container ship Ever Given lost steerage due to strong crosswinds. This 220,000-ton vessel then collided with the sandy bank of the Suez Canal. It subsequently rotated, completely blocking the narrow waterway and effectively closing the planet's crucial trade route. In an instant, global trade was paralyzed, with every hour of delay costing the world economy an astonishing $400 million. Hundreds of ships quickly formed a colossal queue as no one could dislodge the massive container vessel. The efforts of the port tugboats proved futile. How could they move something so deeply embedded in the earth? Help arrived in the form of the tugboat Alpguard, a true heavyweight boasting an immense 285 tons of pulling power. Thus began a highly intricate operation, meticulously planned and executed, which would span several days. The tug strategically worked to dislodge the colossal ship, employing various tactical maneuvers to create movement. A constant danger loomed. An overly aggressive pull could potentially crack the ship's steel hull under its own immense weight. The predicament seemed insurmountable until a stroke of luck arrived with the full moon's celestial influence. This lunar event triggered a powerful high tide, causing the water level in the canal to rise by a crucial 45 centimeters. For the waiting tugboats, this natural phenomenon presented a decisive and much-needed opportunity. 10 vessels, acting in perfect unison, then engaged their engines to their absolute maximum capacity. The sheer force of tens of thousands of horsepower churned the canal water into a frothing, turbulent foam. With each powerful surge, the rescue teams painstakingly pulled the colossal ship's bow free from the sand's grip. This triumph was a testament to impeccable timing and precise calculations, making the most of the natural advantage. Few realized the true cause of the grounding was a rare physical phenomenon known as the bank effect, which literally suctioned the vessel to the canal bed. The tugboats were, in essence, the sole means capable of countering this invisible yet incredibly powerful force. But how could the tug captains ascertain the exact direction to pull when their bridge offered no view beyond the enormous ship's hull? At this critical juncture, control was assumed by a specific individual, whose every command became an absolute directive. When a massive liner navigates the narrow entrance of a port, its captain essentially delegates command to a specialized pilot. This expert possesses intimate knowledge of every underwater contour and hidden detail within the harbor. From their bridge, the tugboat captain's view is entirely obscured by the colossal ship's hull, which dominates the horizon. Unaware of events beyond the massive vessel, the tug captain operates exclusively by strict radio instructions. It's akin to driving blindfolded, relying entirely on a navigator's precise instructions for acceleration and movement. Yet a palpable tension grips these seasoned professionals when the gap to the ship's side narrows to mere meters. The underlying reason for this apprehension is the dangerous suction effect, a powerful hydrodynamic force. As water rushes rapidly between the vessels, it creates a powerful low-pressure zone. This force can literally draw a smaller vessel directly beneath the hull of the larger ship, a terrifying prospect. A particularly infamous incident illustrating this phenomenon occurred in 1911, an event etched in maritime history. The colossal liner Olympic, the Titanic's sister ship, was making its departure from port on that fateful day. Alongside it sailed the large escort cruiser HMS Hawk, maintaining a close but seemingly safe distance. However, the suction effect caused the cruiser to suddenly lose all steerage and veer uncontrollably. It was violently propelled directly into the giant liner's side, a shocking and unavoidable impact. A catastrophic collision ensued, demonstrating the immense, often unseen, forces at play in confined waters. But why do seasoned professionals grow anxious when another vessel approaches within mere meters? The answer lies in a powerful phenomenon known as the suction effect, or Venturi effect. The velocity of water flow between two adjacent ships dramatically accelerates, creating a significant zone of low pressure. This low pressure area effectively pulls the smaller vessel directly into the hull of its larger counterpart. The 1911 incident involving the Olympic and HMS Hawk compelled the entire maritime world to rethink navigation protocols in constricted channels. Today, tugboat captains are acutely aware of this danger and the precise timing required to counteract it. They understand that failing to increase thrust at the critical moment will inevitably pin their vessel against the giant, leading to disaster. Sometimes, however, quick decisions must be made in situations of complete technical failure. Picture a dense fog where, in the very middle of a channel, a cargo ship's rudder suddenly jammed. The enormous mass of the steel vessel began to drift uncontrollably towards a marina full of private yachts. A tense, heavy silence fell across the radio channels as the impending catastrophe loomed. Then a terse, urgent command cut through the quiet, galvanizing the nearby tug crews. Two tugboats, pushing their engines to the absolute limit, managed to brace against the ship's side just seconds before impact. They bravely used their own robust hulls as a shield, preventing the destruction of dozens of smaller boats. Yet, the true arduous work for these mariners often begins far beyond the safety of the shore, where the open ocean's wild waves commence. Imagine a scenario where a raging ocean, a violent storm, and a disabled oil tanker collide. Inside the vessel, temperatures had reached critical levels, causing a thermal wave to alter the very structure of its metal. At any given moment, the ship's steel hull risked losing all its integrity due to the intense heat. In such extreme circumstances, conventional rescue services were utterly powerless to act. It was precisely then that specialized ocean-going rescue tugs materialized from the thick, engulfing fog. These vessels are true maritime fortresses, engineered to endure waves as towering as a 3-story building. But what becomes of a ship that has already reached the critical point of nearly capsizing? A truly unique incident unfolded in the treacherous Bay of Biscay back in 2016. The car carrier Modern Express had developed an alarming list of 51 degrees. This colossal 164-meter-long ship was literally lying on its side, completely at the mercy of the violent storm. It was steadily drifting towards the French coastline, advancing at a persistent speed of 2 knots. Any endeavor to secure a tow line carried the grave risk of capsizing the rescue tug itself. Despite these immense dangers, the crew of the Spanish tug Centaurus managed to achieve the seemingly impossible. Amidst the ferocious storm, they successfully managed to secure a tow line to the critically listing vessel. For an entire week, they towed it through colossal waves, valiantly preventing it from crashing into the jagged rocks. Continuing from the previous dangers, even a slight misstep could trap a person between colossal steel hulls weighing thousands of tons. Beyond external forces, even a technical miscalculation by a ship's crew can lead to equally perilous and dangerous outcomes. A striking example occurred in 2006, when the world saw images of the enormous vessel Cougar Ace, frozen in the ocean at a terrifying 60-degree angle. This particular ship was transporting a massive cargo of 4,700 brand-new Japanese sport utility vehicles. A critical technical error during the transfer of ballast water caused the vessel to lose its stability and dramatically list onto its side. Nearly 5,000 vehicles hung precariously, secured only by their lashings, under this extreme and dangerous tilt. The immense value of this cargo alone surpassed an astonishing $100 million. There was an ever-present threat that the entire ship could completely overturn and plunge to the ocean floor at any moment. The sheer scale of the disaster made the prospect of a successful rescue operation seem utterly unattainable. Yet, powerful tugboats were swiftly dispatched to the scene, tasked with a truly unique and intricate mission. Their primary goal wasn't simply to pull the ship, but to hold it in a precisely stable position, while engineers inside worked to restore its internal water balance. Even the slightest abrupt movement by a tug could dislodge the cargo, triggering a catastrophic domino effect. If just one car broke free from its fastenings, the 55,000-ton vessel would instantly capsize. For several days, the tugboats executed their work with incredible precision, expertly compensating for the relentless ocean waves and strong winds. This was an arduous battle for every single degree of inclination, with rescue engineers literally walking on walls inside the ship to activate crucial pumps. Eventually, through the relentless efforts of the tugboats, the vessel was successfully leveled and safely brought into port. This incident went down in history as a prime example of exceptional professionalism, yet it also underscored the delicate balance an enormous object can possess. It clarifies why operating a tug isn't merely about brute force, but about the subtle art of sensing a ship's immense mass through a taut tow line. However, while tugs are busy saving ships out in the open ocean, a different set of challenges can emerge within the confined spaces of a port. Have you ever considered why a single hour of a port tug's operation can cost several $1,000s? The answer lies in the colossal overhead expenses and the immense responsibility shouldered by the captain. Even a minor miscalculation during mooring can inflict significant damage to the dock or the ship's hull, leading to millions in reparations. Within the complex economy of a port, time stands as the most precious and expensive commodity. Any delay by tugboats triggers a domino effect, pushing back vessel unloading schedules and leaving thousands of trucks stalled in long queues. Port operations are timed down to the second, with every movement meticulously overseen by automated systems. But what would happen if the human element were to be removed entirely from this intricate chain? The world of maritime navigation is on the cusp of a major transformation, as trials for the first autonomous AI-powered tugboats are already underway in major ports. These advanced machines are equipped with an array of cameras and lidars, granting them a full 360-degree view of their surroundings, even in complete darkness. Their onboard computers can calculate rope tension with kilogram-level precision, effectively eliminating the risk of tilting or a snapped tow line. It may seem that robots could outperform humans, but veteran seafarers hold a different, strong perspective on this. A seasoned tugboat captain discerns the immense load not merely from instruments, but through the sensation in the soles of their feet. The subtle vibrations of the deck can signal an unusual situation far sooner than any electronic sensor might detect. Can an advanced algorithm truly anticipate an unexpected gust of wind or an unseen, treacherous current beneath the surface? For the moment, artificial intelligence primarily serves as a supportive tool, yet the very nature of this profession is undergoing a profound transformation. Before long, the command centers for entire fleets could transition from the ship's bridge directly into onshore offices. Here, operators would take control of vast vessels using nothing more than sophisticated joysticks and screens. Nevertheless, regardless of how far technology advances, the fundamental core of maritime work remains constant and essential. Consider a chilling scenario. What if, tomorrow, every single tugboat across the globe simply ceased to function? Within a mere 24 hours, the world's most bustling and vital ports would grind to a complete standstill, utterly blocked. Massive cargo ships would be unable to approach their designated berths, and those already docked would find themselves trapped, unable to sail. This would trigger an immediate and total halt to all global trade, with devastating economic repercussions. The impact on the availability of goods in your local stores would become apparent far quicker than you might ever imagine. An astonishing 90% of all products consumed worldwide are transported via the vast networks of the sea. Each of these countless items, from everyday necessities to luxury goods, literally hinges on a single polymer rope from a small tugboat. We commonly overlook these vessels, often perceiving them as nothing more than secondary auxiliary components of the shipping process. Despite all the technological advancements, the fundamental role of these vessels persists, unchanged through time. Consider the immediate fallout if, for just a single day, every tugboat across the globe ceased its operations. Within a mere 24 hours, the world's most critical harbors would become entirely gridlocked and inaccessible. Massive cargo ships would be stranded, unable to reach their berths, while those already docked would be trapped, unable to sail. The intricate web of international commerce would grind to an absolute standstill, impacting every nation. The resulting shortages would hit your local stores with a speed and severity far beyond what you might anticipate. This delicate global supply chain, vital for the movement of countless products, ultimately hinges on these vessels. We often dismiss these workhorses as merely supplementary components of the grand shipping enterprise. Yet, without their immense power, our modern civilization, as we recognize it, simply could not endure. This is arguably the most crucial, yet simultaneously most overlooked, profession operating on the world's waterways. A tugboat masterfully transforms an unyielding, colossal mass of steel into a precisely maneuvered, responsive machine. Here, sheer engineering prowess and the profound intuition of a human operator who feels the ship's weight always triumph over mere scale. If unraveling the hidden mechanisms behind our planet's logistics sparked your interest, please consider subscribing and giving us a like. We are committed to continuously uncovering the most extraordinary insights about the technology that reshapes our everyday reality. Tell us in the comments which ship rescue story resonated with you most, and join us next time for knowledge rarely found in textbooks.